Welcome back. This video clip will start discussing the factors that affects the amount of diffraction. It's also called the degree of diffraction. The first factor is the width of the gap through which the waves will be moving. Now here you see an animation of waves coming in towards the gap. So this is the gap. Gap here. And you see that there is hardly any bending of the waves as they move through. Most of the wave front is straight going through. And you also see in this demonstration the little points of zero disturbance going here. So that illustrates the points of nodal lines, and that diffraction is actually an interference between these little, formed by the interference between the little wave lits, like Higgins explained. So here we have another set of zero disturbance lines, beautifully animated in this animation. So you can look, the distance between the wave crests is very small compared to the gap width. So if the gap is large compared to the wavelengths, the amount of bending of the waves is very small. So this is just a stationary diagram showing the gap between the obstacles in the path of the wave is much bigger than the wavelength, so you have very little bending around the edge of the obstacle. So the waves are moving towards the right, and you've got a wide gap, so very little bending takes place. Here we have the bending of the waves through a very small gap. You can see that the wavelength of the waves are much bigger than the little gap between the obstacles in its path. So you get a lot of bending of waves as they move through the gap. I want to comment on the 1 and the 0 and the -1 you see there. They are the positions of the antinodes. So the little light bands, if you were looking at a diffraction pattern of light, they would be the light bands in your pattern. The nodes, they are the places of destructive interference. They will be dark bands when you look at a light pattern. Here we have a stationary demonstration of the waves moving towards a gap that is much smaller, and the degree of bending of the waves is much bigger. So the smaller the gap, the more the bending. If we can make a mathematical relationship between the degree of diffraction and the gap width, we can say the degree of diffraction is inversely proportional to the gap width. Now sometimes they use a kind of a W or sometimes they use D for the gap width. Depends on the person who is presenting the lesson or writing the textbook. Right, so we have looked at water waves or simulated water waves. I want us to, on the next slide, go and look at what happens to light when it moves through. They call it a gap or an aperture. So here we have light coming in towards a gap here, and the light makes diffraction pattern. The diffraction pattern is this part here. Oh, my color doesn't want to work now. This is the diffraction pattern. Where the light coming straight through from the gap makes a wide and a bright colored gap here. While that is a position, it's an antinode, and it's the position of constructive interference. Here we have another little red spot on the screen, and there we have another little red spot on the screen. The red spots are separated by dark spots. They are the nodes formed. Then to the left of the diffraction pattern, you see what we call an intensity graph. The central bright spot has got a high intensity of light coming through, where so this is your high intensity central band here. Then you have a low intensity band at position 1 and another low intensity band at position 2, and between the light bands we have places of zero intensity. So those are your nodal lines caused by destructive interference. When you look through, when you look at the diffraction pattern formed by a narrow slit, you will see a much wider central band because it's what will be in the middle of the diffraction pattern, and a wider dark band there, and then there's not enough space on this diagram to illustrate the constructive interference at position 1 and -1. You'll see that the intensity of the light is much higher in the middle than towards the edges. So the narrower the gap, the higher the degree of diffraction, or as I've said in the previous slide, the degree of diffraction is inversely proportional to the gap width. I hope you enjoyed this video clip. The next one will discuss the second and last factor that affects the amount of diffraction.